right, calculating independent and dependent events. Now let's calculate the probability of compound events using what we call the multiplication rule of probability. When finding the probability of combined independent events, you'll need to start by finding the probability of each event individually. Since they do not affect each other, the same process is used for theoretical and experimental. Once you find the probability of each event occurring, you just need to multiply them together. After multiplying the two probabilities you're given, for example, a marble, and you have 1 out of 25 chances, you replace it, that first event and second event don't affect each other. When calculating dependent events, the same concept is used. However, the probability of that second event on what happens must be taken into consideration. So when we take two marbles and we don't replace that second marble, then the total marbles is now less. So here's the example of the marbles. This first one, if you want to take a bag of marbles and you want to pick a black and then a black again, with replacement, we have equal amounts, 2 out of 10, 2 out of 10. But the second scenario on the right, when we do not replace that first marble, the amount of black marbles left is now down to 1. We have a total of now 9 marbles left. Example 2. A number cube is rolled 3 times. What is the probability of 3 even numbers? So here's our number cubed, and these are the favorable outcomes that are highlighted here in purple. And a number cube is always an independent event. So the probability of even times even times even, well, one event over here is a 3 out of 6 probability, or if we reduce that to 1/2, so that's one event. So now we just go ahead and multiply 1/2 times 1/2 times 1/2, which is 1/8. B. 10 cards are labeled 1 through 10 and placed in a box. One card is selected at random and then it is replaced. So again, another independent event. Another card is selected at random. What is the probability of both of them being even? So favorable outcome, favorable outcome, favorable outcome, favorable outcome, etc. So the number of favorable outcomes is 5 out of 10, or 1/2. So now we say the probability of an even and another even, we just multiply 1/2 times 1/2, which is 1/4. Stacy rolls a number cube and flips a coin. What is the probability that she rolls a 5 and then it lands heads up? So both of these events are considered independent events. So the first event, the favorable outcome is a 5. So 1 out of the total in sample space, 6. The second event, heads, is the favorable, sample space 2. So what we do is we multiply, I'll call this the probability of A, the first event, and this is the probability of B, the second event. We just multiply the two events together. The probability of A times the probability of B. So we get 1/6 times 1/2 We multiply across, giving us 1/12. Now we're going to change to dependent events. A bag contains 5 marbles that are red, 3 that are white, and 4 that are blue. What is the probability if we randomly select a marble that is red and we set it aside? So this means no replacement. So it is dependent. So here's our first event. We have a total of 5 red marbles is our favorable out of a total of 12. So 5 out of 12. Now we have the second event. Notice the number of marbles has decreased by 1, and the number of red marbles has also decreased by 1. So we have 4 red marbles left out of 11. So we multiply these two events together. So 5/12 times 4/11, and we multiply across. Ten cards are labeled 1 through 10 and placed in a box. 1 card is selected at random and not replaced. Another card is selected, and what is the probability of them both being even? So here's our first event, the probability of A. The number of evens are all the ones in the yellow here. So you have 5 out of a total of 10. The second event, notice now we have 1 less card. We're down to now 9 cards, and the number of evens has now decreased also, 4 out of 9. So all we do is we just go ahead and multiply those two events together. The probability of A times the probability of B equals 5/10 times 4/9, multiply across, 2 out of 9. All right, here's our last one. A game has 6 colored plain pieces. They are red, yellow, green, blue, purple, and white. And your friend picks a piece without looking. What is the probability that your friend picks the blue and you pick the yellow? So this means at the same time. So no replacement is happening. So here's your friend, and you want the blue. So here's the blue one. So 1 out of 6. Now at the same time, you are picking from that same piece, but now the blue is gone, and you're going to pick yellow. So 1 out of 5. So we just go ahead and multiply the probability of A times the probability of B is 1/6 times 1/5, or 1/30.